Good evening. We'll continue what we left yesterday. Yesterday we were working some problems on trigonometry. So today we move on to the KCET problems only. Sine 1 degrees plus sine 2 degrees plus sine 3 degrees, etc. plus sine 359 degrees. Very interesting problem. You need to have a knowledge of right angles. I will recall what we did yesterday. Even multiple of 90 plus or minus theta, trigonometry function will not change. Odd multiple of 90 plus or minus theta, trigonometry function will change. So what we do is, we will write sine 359 as sine of 90 into 4 minus 1 degree. 90 into 4 is an even multiple, so it will not change. Sine has to remain as sine. But 90 into 4 is fourth quadrant minus, it is the fourth quadrant only, where sine is negative. I repeat, ASTC. 360 minus theta is in fourth quadrant. 360 plus theta is in first quadrant. 360 minus the first quadrant, this is fourth quadrant, where sine is negative. Therefore, this is minus sine 1 degree. So this is going to be minus sine 1 degree. Similarly, if you take sine of 358, you will get 90 into 4 minus 2 degrees. That is minus sine of 2 degrees. So this will be minus sine 2 degrees. So this will cancel, this will cancel, this will cancel, and this will cancel. So you are left out with one value sine of 180 degrees, because it can't be expressed in any other form. So therefore, only possibility is sine of 180 minus 0. 0, it is going to be sine 0. There is no sine 0. But we know the value of sine 180 is 0. Therefore, answer for this is 0. So if you have a clear knowledge of allied angles, this is a very simple problem. We'll move on to the next problem. The next problem is, if 1 plus sine theta plus sine square theta plus etc. up to infinity is 2 root 3 plus 4. 2 root 3 plus 4. Then theta equals. Very good question. A very simple one. Only thing is, you need to realize 1 plus sine theta plus sine square theta plus etc. It's a geometric progression. It's a GP. That is what you should realize first. 1 plus sine theta plus sine square theta etc. Up to infinity they have asked. They have not asked up to any terms. Up to infinity they have asked. But you should remember, here A is 1, R is sine theta. And the formula for S infinity is A over 1 minus R. The first point that is important is to recognize the given problem is geometric progression, where A is 1, R is sine theta, and you should remember the formula for sine infinity, rather S infinity, A over 1 minus R. A is 1 minus R is 1 minus sine theta. That is given to be 2 root 3 plus 4. I repeat, the first step is to realize the given problem needs a knowledge of geometric progression. It's rather geometric progression with A being 1 and R being sine theta. So we use the formula. Now we have to just simplify this. Let us cross multiply. you get 2 root 3 minus 2 root 3 sin theta plus 4 minus 4 sin theta is equal to 1. I have just cross multiplied this. Now we have to find the value of theta. That means you have to find the value of sin theta. Once you know what is sin theta, from that you can get. So you have to find an expression for theta. Rather sin theta we shall need to find out. You got 2 root 3, 4 and 1. So this is 2 root 3 minus plus 3. 4 minus 1 is 3 is equal to 2 root 3 sin theta plus 2 sin theta. See, what is it we can take common? You can take root 3 common here. You get 2 plus root 3. You can take, what is the maximum common factor you can take? You can take 2 sin theta common. You will get root 3. Oh, this is not 2 sin theta, this is 4 sin theta. I'm sorry. Because you got 4 sin theta. You will get root 3 plus 2. So these two will cancel. So you will get sin theta is equal to root 3 by 2. Therefore, theta is equal to 5 by 6. It's a very, very simple problem, provided you have knowledge of geometry progression, and that is why we insist on working previous year's problem. Because the next year, instead of sin theta, they may give cos theta. Let's move on to the next problem. The next problem, it's a problem which has been repeated in the examination number of times, but we shall work again so that by working that problem, in case if it is repeated again, you can work it out easily. The problem is the value of tan 1 degrees into tan 2 degrees, etc. tan 89 degrees. See, this problem has been repeated number of times. So you can write the answer without even working the problem. You can remember. But let me work. In case if the same problem is repeated, you can, from memory, you can take it and you can call that as a problem, rather a problem of memory. See, what we do is tan 89 degrees is nothing but cot 1 degrees. Because you can write tan 89 degrees. Right angle is very, very important. 90 minus 1. 90 minus 1 is odd multiple. Tan has to change. It will become cot 1 degrees. So here you will be having tan 88 degrees. That will be equal to cot 2 degrees. So tan 1 degrees and cot 1 degrees, the reciprocal function, you will cancel. Similarly, everything cancel, you can cancel 1. So they have repeated this problem a number of times. You can directly take the answer. But 1 year, they played a trick. The same problem was given in a slightly different way. Let me take that problem. The same problem, different way. The value of you must realize the problem that I am writing and the problem that we worked are one and the same. The value of e to the power of log e to the power of tan 1 degrees to base 10 into e to the power of log tan 2 degrees to base 10, etc. e to the power of log 89 degrees to base 10. The answer is 1. It's the same problem, you should realize, but it has been given in different form. What is the knowledge you require? You require e to the power of log of f of x is f of x. So this problem, if you apply this, it is the same problem. Answer is 1. So these are the simple tricks played by the examiners. So if the concept is clear, you will not have any difficulty. I think with that we'll move on to the next chapter, that is complex numbers. I have got to just give you some briefing, only then you can work the problems. So let me give some briefing, minimum briefing, with that we can see what we have got to do is, first we should recall what is a complex number. A number will form x plus I y, where x and y are real numbers. I is an imaginary number. I is an imaginary number. I is equal to root of minus 1. I square is equal to minus 1. Are called complex number. Complex numbers are denoted by z. Then we need to know the modulus of a complex number. Because the problems are mostly asked modulus. Modulus of z is equal to root of x square plus y square. So we say mod z is equal to root of x square plus y square. Modulus of z1 into z2 is equal to mod z1 into mod z2. These formulas are very important, especially for CET. Modulus of z1 by modulus of z2 is equal to mod z1 divided by mod z2. The other thing they ask is what is called conjugate. Conjugate of z is denoted by z bar. All of you know this, but I am just helping you to recall. If z is equal to x plus iy, then z bar is equal to x minus iy. Next, you need to remember multiplicative inverse, because they have asked this question in CET. Inverse of z. Remember the formula, it is z bar by mod z whole square. If you don't remember the formula, then you have got to work it out. But if you remember the formula, it is going to be easy. One more thing you need to remember is modulus of 1 plus I by 1 minus I is equal to I. And modulus of 1 minus I by 1 plus I is minus I. Whether you take modulus, even if you don't take modulus also, it is going to be I and this is going to be minus I. So you need to remember a complex number. You need to remember the conjugate of the complex number. You need to remember modulus of z, and modulus of z1 and z2 is mod z1 and mod z2, and this one plus multiplicative inverse of z. With this knowledge, we will try to work some problems given in the examination. In fact, even if you don't write modulus also, you can remember like that also. 1 plus I by 1 minus I, 1 minus I by 1 plus I. 1 plus I by 1 minus I is I, 1 minus I by 1 plus I is minus I. This will help you a long way in simplification, many problems, especially they have asked in CET. So let's start with the first problem that I have listed. In CET 2020, there is a question. on complex numbers. If 1 plus I by 1 minus I to the power of n is equal to 1, then n is equal to what is n? See, normally a problem like this is given. We have got to work it out by multiplying by 1 minus I, rationalizing and all that. But if you can remember, this is 1 plus I by 1 minus I, therefore this is equal to 1. See, you have to recollect. I is equal to root of minus 1, I square is equal to minus 1, I cube is equal to minus I to the power of 4 is equal to plus 1. So because it is 1, therefore n should be 4. In the answer given, if n is equal to 4 is given, okay. Sometimes they give the answer as n is equal to 4n, or n belongs to z. That means if you get 1, I to the power of n number is equal to 1, that number n should be a multiple of 4. If they are given the answer as 4, you can take that. Sometimes they don't give 4, they will give you multiple of 4. That means you can write 4n. That is one problem. The very next year, they have asked a problem 1 minus I over 1 plus I whole square. What is the value of this? See, 1 minus I by 1 plus I is minus I whole square. It is minus 1 only. Why? When you square it, minus sign will go, you will get I square. I square is minus 1. See, why this problem is given in the examination is, in a hurry, student may take the answer as plus, because the power, when it is even number, the minus sign will become plus. Definitely, minus sign will become plus, but you are getting I square, but I square is minus 1. And invariably, they would have given answers plus 1, minus 1, 0, something like that. In 2018, there was a problem 1 minus I to the power 1 plus I to the power of 96. You can realize 96 is a multiple of 4. I to the power of any multiple of 4, the answer is going to be plus 1. Whether that you have got to calculate. How to calculate this? I told you 1 minus I, 1 plus I is minus I. Minus I to the power of 96. 96 even number, this minus will go. You get just I to the power of 96. 96 is multiple of 4, therefore it is 1. 96 is a multiple of 4. The chances are there, a student may write a minus 1 also. You have to be careful. 96 is an even number. Minus 1 to the power of even number is positive. One more question was asked in one of the examination. If 3x plus I into 4x minus y is equal to 6 minus I, find x and y. What you need to know here is, if a plus b, a plus ib is equal to c plus id, then a is equal to c, b is equal to d. Two complex numbers are equal. If complex number equal agಬೇಕಾದ್ರೆ the real part equal, imaginary part equal. ನಾನು ಯಾವಾಗಲೂ ಕ್ಲಾಸಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇರ್ತೀನಿ. a plus ib equals c plus id ಆದರೆ दूध का दूध पानी का पानी ಅಂತ. Real part must be equal to real part, imaginary part must be equal to imaginary part. That concept we are going to use for this problem. Other than that, it is not a difficult problem. So what is real part? 3. So 3x is 6. So you get x is equal to 2. Now, दूध का दूध पानी का पानी. 4x minus y is equal to minus 1. You know x. So 8 minus y is equal to minus 1, y is equal to 9. So So they would have given the answer 2, 9 or 2, 9 without bracket also. If you are in a hurry, you may get 2, 8 also, 2, 7 also. So what is important is simple concept. If two complex numbers are equal, only when the real parts are equal and imaginary parts are equal. Few more problems of CET which will work. One of the problem of CET is Z equals √3 plus I to the power of 3 into 3i plus 4 to the power of 2 divided by 8 plus 6i whole square. Then what is mod Z? Here what happens is, normally we get a feeling we have to expand this whole cube, we have to expand this, multiply that those two, and we have got denominator, that also expand or rationalize it. That will take a lot of time. You can't expect such a question in CET. So you need to remember the formula that I have taught you. Modulus of Z1 into Z2 is equal to modulus of Z1 into modulus of Z2. So let us find modulus of this directly. Mod Z is equal to, what is the modulus of Z? Modulus of Z is equal to root of x square plus y square. So this is 3 plus 1 root 4 whole square. Not whole square, root 3. I repeat, x is 3, x square is, x is root 3, x square is 3, y is 1. And what about this? This x square is 9, y square is 16, so root 25 whole square. And 8 square is 64, 6 square is 36, root 100 whole square. So 4 cube is there, square root of 4 is 2, therefore it is 8. Root 25 is 5, therefore this is 25. And root 100 whole square is, so 25 for the 100, 4 to the 8, the answer is 2. They would have given 2, 3, 4, 5 like that. It's a very, very simple problem. You need to remember modulus of Z1 into Z2 is equal to. The next year they asked a question. Simplify. The problem is simplify. I to the power of n plus I to the power of n plus 1 plus I to the power of n plus 2 plus I to the power of n plus 3. Very simple problem. So you need to remember I square is equal to minus 1, I cube is equal to minus I to the power of 4 is equal to 1. So what we can do, we can take out I to the power of n common. What do I get? I get 1. I get I square. No, this I get. Then I get I square. Then I get I cube. I cube and I will cancel because I cube is minus I and I cube is minus I and I square is minus 1. Minus 1 and plus 1 cancels. And this is I cube is minus I, therefore I and I cube will cancel. You get the answer 0. And let me repeat once again because if it is confusing. When I take I to the power of n common, I get 1 here. Then I get I here because n is taken common. Then I get I square here. Then I get I cube here. As I discussed, because some students will find difficult to follow. 1 is 1 only. I is I only. I square is minus 1 and I cube is minus I. Everything cancels negatively. A very simple problem. One more similar problem of modulus. The modulus of the complex number. The question reads like this. The modulus of the complex number of the complex number 1 plus I whole square 1 plus 3I divided by 2 minus 6I into 2 minus 2I. See, 1 plus 1 is root 2. Root 2 square is 2. This is 1 plus 9. It is root 10. This is 4 plus 36 root 40. That is 2 root 10. So you have got to calculate and write it very fast. This is 4 plus 36 40. 40 is root of 4 into 10. That is 2 root 10. So you can cancel this immediately. This also you can cancel. This is 4 plus 4, 8. That is 2 root 2. See, what happened is, in the answer they have given the answers as 1 by root 2 is the game the examiners play. 4 by root 2, root 2 by 4, and 2 by root. We have got 1 over 2 root 2, the answers are different. So one thing is certain, 4 by root 2 is not possible, 2 by root 2 is not possible. One of them should be true. So what you should do is, you should multiply this by root 2 and divide by root 2. You get root 2 by 4. That's the answer. So this is a game examiners will play. The answer is not given in the format that you get. So you have to reduce the answer to the given format. You should realize, so such questions are also there. You work the problem, you get the answer, but answer will not be in that format. That is why we say CET is difficult. But once you start working the previous year's paper, then you are aware of the games played by the examiners. Absolutely no problem. Let me work one problem of finding the multiplicative inverse. Find multiplicative inverse. First, in CET, they will not give find the multiplicative inverse of 3 plus 4I. 4 answers are given, you have got to take one of the answer. I'm not writing the answer, I'm just giving you the method. See, you should remember, as I told you, multiplicative inverse of Z is equal to Z bar over modulus of Z whole square. So Z bar is nothing but 3 minus 4I. And this is 3, 4 and 5 form a rectangle triangle, therefore this is 25. But they won't give the answer like this. They have given the answer as 3 by 25 minus 4 by 25I. Sometimes they actually other game also. The multiple inverse of 3 plus 4I is x plus I by. What is x? They will not ask y also. So you should write it as 3 by 25. So these are the games played by the examiners. So if you are aware of this, absolutely there is no problem. You can work any problem We have to move on to the next concept. Complex numbers we have completed. Trigonometry we have completed. And sometimes they ask a question on, very rarely, quadratic equations also. On quadratic equations also you get questions. So let me just give you some basic concepts about this. Ax square plus bx plus c equal to 0 represents a quadratic equation, and every quadratic equation has got two roots. The roots are given by x is equal to minus b plus or minus square root of b square minus 4ac divided by 2. Now here b square minus 4ac is called the discriminant. And just repeating this, not that you are not aware of this, but in case if you have forgotten, you can recall. Discriminant. Why this is called discriminant? Because it discriminates the root. So there are possibilities. B square minus 4ac can be equal to 0. B square minus 4ac can be greater than 0. Or b square minus 4ac is less than 0. So when b square minus 4ac is 0, this expression will be 0, and the root is what is minus 2 by b by 2a. In that case, we say roots are equal. So they may ask a question in the CET examination, given one problem, roots of this equation, a equal, imaginary, real, something like that. So if b square minus 4ac is equal to 0, the roots are equal. If b square minus 4ac is greater than 0, this exists, and that number is going to be real. Roots are real and distinct, both are different, because for plus 1 you get one root, so they may give real and distinct. If b square minus 4ac is less than 0, that means you are getting a negative sign inside the root expression. So what will happen in that case? It becomes imaginary. That is one concept you need. The other concept is, if alpha and beta are the roots then alpha plus beta is equal to minus b by a, alpha beta is equal to c by a. So they may ask you to find sum of the roots, or they may ask you to find the product of the roots. Sometimes they will give you all sum is equal to say 4, product is equal to say 6. Find quadratic equation. Find quadratic equation. The problem can be in this form also. They may ask something related to the roots, that is, roots are equal or roots are real or roots are imaginary, based on that. Or they may ask you to find some of the roots or product of the roots, equation is given. Or the other possibilities, they may give you an equation has got sum of the roots is equal to 4 and product of the roots is equal to 6, something like that. Find the equation. For that, you need to remember the formula. Equation is equal to x square minus sum of the roots into x plus product of the roots is equal to 0. This formula you need to remember. X square minus sum of the roots into x plus product of the roots. So for this problem, sum is 4, and therefore you can write the equation of x square minus 4x plus 6 equal to. Earlier there were the problems based on find 1 over alpha plus 1 over beta, things like that. Nowadays we don't find that questions in case if it is repeated. So you should know how to get alpha plus beta, and alpha beta. Normally, the quadratic equation questions are going to be about roots. Okay. So we have covered what was left over in trigonometry, and normally you get only one question or two questions from complex numbers. So I repeat, what are the possible questions from complex numbers? Modulus of a complex number is root of x square plus y square. The multiplicative inverse of z is equal to z power over modulus of z whole square. And other thing you need to remember is 1 plus I over 1 minus I is equal to I. 1 minus over 1 plus I is equal to minus. And other I square is equal to I is equal to root of minus 1. I square is equal to minus 1. I cube is equal to minus I. And to the power of 4 is equal to 1. So whenever they ask you to find I to the power of any number, supposing you get a equation I to the power of 147, supposing it is asked. And that means you get a situation like that. So first you should decide I to the power of 4 to the power of how much? Let us divide this by 4. 4 3 is 12. 2 is left over. 4 6 is 24. So 336. How much you get? 6 4 the 24. 144 you get. You are left with IQ. So this is 1. This is minus. So if you are going to simplify in I power, you separate the multiple of 4. Whatever is left over here, what happens is you have the 147. I to the power of 4 to the power of 36. I to the power of 4 is 1. To the power of 36 is 1 only. You are left. This is 144. It is 147. Another 3 is there. And you remember IQ is minus. So this is work. You should remember. I is root of minus 1. I square is minus 1. I cube is minus I. I to the power of 4 is. Once you know these 4 things, you can work any problem on this. Now we'll move on to the next concept, that is sequence and series. Here also, at the most, you get one question or at the most 2 questions, not more than that. Here we have AP and GP. These days you find the problems on AP and GP very simple, provided you have a clear idea of what is AP and GP. So I have told you that I will be concentrating more on the concept, because I have got my own limitations of working some problems. Writing all the answers are not possible in times. Working the problems and asking you to choose the answer. So one of them is the answer. It may be A, B, or C, whatever it is. I'm only guiding you how to work the problem. So let me give some concept about AP. Just try to be as brief as possible. A plus B, A plus 2D. The numbers are like this. It is called an AP. Here A is called the first term and D is called the common difference. You need to know the expression for Tn. What is Tn? Last term or the nth term. It is A plus n minus 1 into D. You need to remember the formula for Sn. What is Sn? That is sum of n terms. It is n by 2 into A plus Dn. Or the other form is n by 2 into 2A plus n minus 1 into D. Either A plus Tn or this. See, what is that we have done is, for Tn we are writing A plus n minus 1. So that becomes 2A plus n minus 1. You can use this formula when you know A in Tn. You can use this formula when you don't know Tn, but you can find Tn using, or directly you can find using this formula. So this is all about arithmetic progression. One more you need to remember is 3 terms in AP. Remember it as A minus D, A and A plus. Because I'm not going to a particular problem, I'm just explaining. Sum of 3 terms of an AP is given, the product is given, find the AP. So when you add this, what happens when you add this A minus D, A plus D? You will notice D will cancel, you will get a value of A. And you can find a product equation, you can find and substitute the value of A. So these are the basic ideas you need to know about the arithmetic progression. The form of the arithmetic progression A plus D, A plus 2D, etc. A is called the first term and D is called the common difference. And then you need to know the expression for Tn, A plus n minus 1 and D. Then Sn, there are 2 equations I have given you. And other possibilities, they'll ask you, they'll say sum of 3 terms in AP is so much and product of 3 terms in AP is so much. Find the AP. Don't take it as A plus D, A plus 2D, you take it as A minus D and A plus D. That is one thing. Then about GP, geometric progression. It is AR square, etc. Here also A is called the first term. D is called the constant ratio. Not common, it's called constant ratio. You need to know what is Pn, the nth term. It is AR to the power of n minus 1. You need to know Sn. A into R to the power of n minus 1 by R minus 1, or the other formula is A into 1 minus R to the power of n by 1 minus R. Use this formula when R is greater than 1. Use this when R is less than 1. Supposing you interchange and use also, no problem. The only advantage is when you use this when R is less than 1, you can avoid a minus sign. That's the only advantage. Otherwise, any formula is okay. A into R to the power of n minus 1 by 1 R minus 1, or A into 1 minus R to the power. One more thing you need to remember is S infinity. A over 1 minus R. I think you can recall, we worked a problem in trigonometry. If you remember, 1 plus sine theta plus sine square theta plus etc. up to infinity. Just today's class only we worked. For that we have made use of this S infinity, where A is the first term, 1 minus R. So if you know this much, plus just as in AP, 3 terms here also you should remember. So you can remember 3 terms in GP. Three terms in GP, A by R, A and AR. A by R, A and AR. Because what happens is when you multiply, if you are given the product, when you multiply, the R will cancel, you get A. Once you get A, you can find R using that other one. Here also, the problem can be the sum of the 3 terms in AP is rather GP is given, product is given. You have to find the GP. I think with this basic ideas, we can work problems. Let us work the problems that have been asked in the CET. See here, I have told you in the first class when I conducted on Saturday. The moment you notice the problem is running into 2 or 3 lines, don't do it in first steps. First round, you have to go for second round. No, here's one. Normally, some of the problems in sequence and series will run into 2 lines. But we are going to work. Only thing is we can postpone it to second round. Let us take the problem. Consider an infinite series. I will write the question so that you will have a clear idea. Consider an infinite geometric series. The problem is not difficult, but wordings are more. Infinite geometric series with first term A, with first term A and common ratio R, or constant ratio or common ratio. Constant ratio R. Constant ratio R. If the sum is 4, sum to infinity is 4. If the sum to infinity is 4, and the second term is 3 by 4, and the second term is 3 by 4, then you are asked to find A and R. Find A and R. The problem looks lengthy, but it is not difficult. So how to work this problem? They are talking about sum to infinity. So you need to know the formula for sum to infinity. S infinity is equal to A over 1 minus R. That is given to be 4. So what is that you are going to get? A is equal to 4 into 1 minus R. One equation you have got. What is the second equation? The second term is AR. AR is equal to 3 by 4. So these two you have. This one equation, other equation. There are two equations, there are two variables. So what we can do is, I can replace A by this. A is 4 into 1 minus R into R is equal to 3 by 4. So you can bring this 4 this side. 1 minus R into R is equal to 3 by 12. So 3 by 16. So you can simplify this. R minus R square is equal to 3 by 16. Or 16R minus 16R square is equal to 3. Write it properly. 16R square minus 16R. Taking the other side. Plus 3 equal to 0. You are getting a quadratic equation. You have to solve this quadratic equation. How fast you solve is very important. You have got 6 and 16 and 3 factors are 48. 12 fours are 48. So you can write this as 16R square minus 12R minus 4R plus 3 equal to 0. 4R is common. 4R minus 3. Here minus 1 is common. 4R minus 3. You can stop here only. R is equal to 3 by 4 or 1 by 4. Then you can find what is A. If R is 3 by 4, what is A? You can find out. So AR is 3 by 4. A should be 1 in that case. When R is equal to A, R is equal to 1 by 4, what is A? You can find out. The difficulty here is the difficult problem. How to work it out? So when you start finding the equation, you get a quadratic equation, solve a quadratic equation, and you have to work it out. But I would rather suggest a method for this. I have not listed the answer, 4 answers, but what you can do is, you can substitute the answer in this equation. See, they would have given A is equal to what are the answers that we have got? We got R is equal to 1 by 4. When R is 1 by 4, R is 3 by 4. So A into 1 by 4 is equal to 3 by 4. 4 and 4 cancel. A is equal to 3. So I can put the value of A as 3. And what is R? R is 1 minus 3 by 4. R is 1 by 4. R is 1 by 4. So it is 3 over 3 by 4. That is equal to 4. That's the answer. I think you got it. Whenever you find an equation is difficult to solve, go for elimination method. And especially you can 4 answers given. If A is same and R is different, and if don't choose an answer where both A's are same, choose any one of them. And the only thing is you are depending on luck. By chance the first answer is right, you save some time. Even otherwise, instead of working all this, elimination method always works out. You have to just substitute this. It will not take more time. So this is what I am suggesting. After working, why did I want the problem? Just to make it very clear to you, if you start solving the usual method, it takes time. So this is a problem where you can get a solution from the solutions. Okay, let's move on to the next problem. If second and fifth term, if second and fifth term of a GP, they have given GP of a GP or 24 and 3 respectively, or 24 and 3 respectively. Then sum of first 6 terms. Then sum of first 6 terms. What is second term? AR is 2. What is fifth term? AR to the power of 4 is second term is 24 and this is 3. You can cancel this. You get 1 by R cube is equal to 8. So R cube is equal to 1 by 8. R is equal to 1 by 2. Is this clear? Normally, whenever 2 different terms are given, divide 1 by the other. So you get 1 by R cube is equal to 8, or R cube is equal to 1 by 8, R is 1 by 2. Now you can get the other one. What is second term? AR is given to 24. What is R is 1 by 2. So A is equal to 48. The problem is not over. They want S6. You know R is less than 1. So use the formula A into 1 minus R to the power of n by 1 minus R. What is A is 48. 1 minus half to the power of 6. 1 minus half. So this minus half will come up, it becomes 96. This is 2 to the power of 6. 2 to the power of 5 is 32, 2 to the power of 6 is 64. 64 minus 1 is 65 divided by 64. You can simplify and get the solution. So 64 is there. 16 6 16 4 3 2 2 3 so you get the answer 60. I'm sorry, this is 63 now. This 64 minus 1 is 63. You get the answer 186 by 2. That's the answer given in the book. Repeat again. Now they have given you second term, that is AR. Fifth term AR to the power of 4 is 24 by 3. We divide. So 1 by R cube is 8 cube, or R is equal to 1 by 2. Then use the formula. I am using this formula because R is less than 1. Otherwise, you get a minus and that you have got to adjust. So what happens? The 1 minus half is half. Half will come up. This is 96. This is 2 to the power 64. 64 minus 1 is 63. Not 65. You have to cancel it. 16, 6 and 16. Or you can work it out by any other method. Finally, you get the answer 180. Simplification is your skill. How fast you do it is left to you. There's another problem of the same type. The third term of a GP is 9. The third term of a GP is 9. The product of its first 5 terms. The product of, it's a very interesting problem, of its first 5 terms. So you have to find the product of first term into second term into third term into fourth term into fifth term. First 5 terms. First term, second term, third term, fourth term. First 5 terms is e to the power of one mistake has happened. This is a square, this is a cube, and e to the power. First, find out what is to be found out. You have to find the product of first 5 terms. So if you multiply this, you are getting e to the power of 5, and 4 plus 3 is 7. This is a to the power of 10, or r to the power of 10. That is nothing but a r square to the power of 5. But a r square is 10. Therefore, 9 to the power of 5. They would not have simplified. They would have given the answer 9 to the power of 5. The only thing you have to realize is something, they have not given any much data. They have only given third term. That means this can be expressed. So multiply this. First term, second term, third term, fourth term. You get e to the power of r to the power of 10. That is a r square to the power of 5. A r square is third term. Therefore, that is 9 to the power of 5. Next problem, let's also on GP. If A1, A2, A3, etc., A10, if A1, A2, A3, etc., A10 is a geometric progression, is a GP. Is a GP. A3 by A1 is 25. A3 by A1 is 25. Find A9 by A5. Find, very interesting problem, A9 by A5. Analyzing the problem is very, very important. They are given A3 by A1. You should know what is A3. A3 is A or square. A1 is A. That is 25. Very simple problem if analyzed. So R is equal to 5. Over the problem. First part of the problem is over. Now, if R is equal to 5, R is equal to 5, you can find out what is A also you can find. Always let us work out this. A to the power of 9 means A or to the power of 8. A to the power of 5 is A r to the power of 4. You will not find A, you can cancel A here. So this is r to the power of 4. That is 5 to the power of 4. 5 to the power of 4 is 25 square, 625, or they would have given us 5 to the power of 4 only. I think so the problems asked, very simple problems they've asked. This is another problem. It's lengthy, but we should work it out because it's a problem asked in the CET examination. If A, B, C, if A, B, C are three consecutive terms, terms of an AP. And XYZ and XYZ are three consecutive terms of a GP. Three consecutive terms of a GP. Then find x to the power of b minus c into y to the power of c minus a into z to the power of a minus b. Very interesting problem. Here, one thing you must understand, there are so many variables. So let us try to reduce it to minimum number of variables. If A, B, C are in AP, then 2B is equal to B plus C, A plus C, or B is equal to A plus C by 2. This is what you need to remember. Now X, Y, Z are in GP. So we shall take the term as first term is X, second term is XR, third term is XR square. That means this is X only, this is Y, this is Z. Because when 3 terms are AP, they should differ by a constant ratio. Now we are going to substitute in this x to the power of b minus c. You write b minus c as it is, no problem. And this is y is nothing but x to the power xr to the power of c minus a, and that is nothing but xr square to the power of a minus b. Did you understand this properly? What we have done is we have taken the first term of GP as x, second term of G, instead of y I have written as XR because they differ by a constant ratio. So now what you have got to use indices clause and simplify. So what do you get for the x? This is b here plus c minus a here plus a minus b here. So what will happen is and here not b minus c here, x to the power of right here b minus c plus c minus a plus a minus b. So everything will cancel, you get x to the power of 0, that is 1. But what about r? R to the power of b minus c plus c minus a, c minus a, very simple problem, plus a minus b. That is also r to the power of 0, it is 1. So if a problem is given in the examination, something like this, first three terms of a consecutive terms of EP and GP, don't worry, the problem is equal to 1. Because you realize that everything will cancel. The only point you need to remember is that instead of taking it as Y, you call it as XR. I think with this, today we shall close our class. So let me just, before you close, let me just recall what are the things that we have discussed today. The first part, we worked some problem on trigonometry, where we brought in the allied angles, was required for that. Then we worked some problem on complex numbers. In complex number, we discussed about the conjugate of the complex number and how to find the modulus. Modulus is root of x squared plus y squared. How to find the modulus of 2 or 3. Then we discussed about the multiplicity inverse of z, that is z bar or modulus of z whole square. Then since we had time, I discussed about AP, GP. So again, let me just write Tn is a plus n minus 1 into d. Sn is n by 2 into 2a plus n minus 1 into d. This is AP. And any three terms is a minus b, a and a plus b. Any three terms. What about GP? Tn is a to the power of n minus 1. Sn is equal to a into 1 minus r to the power of n by 1 minus r, or a into r to the power of n minus 1 by r minus 1. And S infinity is equal to a by 1 minus r. Further, we also discussed about three terms in GP, A. So these are the basic concepts that are required to work any problem in CET of the progressions. So next class tomorrow, we will move on to a very important chapter, very interesting chapter, permutations and combinations. And I will be concentrating only on the problems given the CET, because the permutation problem is very interesting, very important and interesting problems are there. But we have got our own limitations. I am just confining myself to the standard of problems given in the CET examination. In case if you are able to complete that, we can move on to binomial theorem. So again, I am asking the students, in case if you are finding any of the concept that I am working here, little, you need some more explanations, or you want me to brief again, kindly, you can send a message to me. The one message is there. Live, remember, okay, it's not pertaining to me. Okay, somebody has thanked me for the class. Anyway, let's close today's class. I would rather suggest, before you come to the next class, revise something about permutation. You know, permutation means arrangement, combination means selection, and you have the what is called NPR, NCR. Just remember the formulas. So if you have glanced through that, of course I'll be giving the formulas. Basics I am going to discuss, concepts I am going to discuss. But if you have gone through that and come, because especially for the binomial theorem, you will not get much questions in binomial theorem in CET. It's a very big expression. But there are some questions based on the finding a particular term of a binomial expression. Find a 10th term or 15th term and formulas. I'm going to discuss those formulas. But I would rather advise you just go through the basics and come. Then I think that will be, when I just start revising it, that might help you to understand the concept much better. So we shall close the class today. Good night. We shall meet tomorrow at 9 o'clock. Okay. Anything else is there? You can just send a message to me. Thank you and good night.